question. Okay, grading. Number 12 is already up there. Number 14 is in 16, 22, 26 is coming.
Hold on, I'm trying to figure out who did 14.
As you guys are checking the first beginning problems, I'm not scrolling down quite yet. Let me go back since the recorder, we did not pick up our original problem. So in our workspace, we started with section 8.1 practice. Although I think everyone's here today. Went ahead and checked our answers for A, for B, for C. Now we're in section 8.2, but first grading 8.1. All right, I'm caught up. How are we doing?
All right. Ooh, did not get those right. Probably have wrong here. What?
How did you round?
I'm so stupid. I got 2,000.
Yeah, it was.
No, go ahead. For 22, it's an average value.
Let me see.
No, but that would cancel it out. That's why
I'm looking it up, Lucy. I'll come right back.
kilowatts, right?
Any other questions so far on 1 through 26 or on?
Can it be an odd? Or does it have to be?
Yeah, you can get it on. I'm just going to look it up in the book.
Alright.
Which one?
B.
9B. Caroline, which one do you have a question? Because displacement, hey guys, you can answer, guys. If I were to call on a random person, could you tell me what Caroline's question just was? Who can raise their hand and tell me what Caroline's question was? It doesn't sit right next to her. Yeah, Kyle.
She asked why we don't have to include the 15, the initial position.
Okay, for like number 12, right?
Yeah.
Do you guys hear what Kyle said?
No, I just stay quiet.
Okay. Look at the word displacement. Caroline and then Kyle repeated, why don't we include the plus 15, the initial position at 0? Gabby, what do you think?
Isn't it because we're not looking for the total amount that was traveled, we're just looking for where it is at that point? So
Backwards.
Displacement.
John.
Isn't it you're trying to figure out how much it moved from where it was?
Yes. You're trying to figure out where it's ended up from where it began, so we don't need to think about where it began relative to some other position. So think of it this way. This is just looking for how it changed, not where it's at. Does that make sense? So you can think of it this way in the sense of if you, school's over, you start driving home, you're 15 miles from, not 15 miles, whatever, 15 something, we'll just use miles, 15 miles from school, like you've gone 15 miles from school. But then you are like, oh no, I need to go on this errand, this errand, this errand, this errand from that 15 miles. We don't care where you are relative to school, we just care about how much extra mileage you took getting around to all your errands before you got home. So it's like you're looking for just the change in right there, like what ended up happening, as opposed to, oh, how far are you from school? That's not the point. So the point isn't where it is relative to the beginning initial position, but rather just how it changed. And then Alan, you had a question on 9B, and then Lucy had a question on which one, 22?
Yeah.
Okay. Trying to get my book to work. It's not working currently. Let me go ahead and scroll down so you can keep checking a little bit. Oh, that was it. Those are all the evens? Oh, now it's loading. Silly book. Silly technology. Since we only have 9B and 22, we're going to peek at them quickly together. But any other questions on odds or evens? Going once, going twice? Yeah. 25. Okay, as I get ready to look at those, I want you guys to go ahead and start taking notes. That's why I'm not having you guys go to the board. Woo!
Thank you.
Doesn't start too hard. Section 8.2, keep your homework spirals out so that we can go over those questions in just a second, but start taking motion that we had. How do you do with motion? She's back. Okay, 9B. Let me zoom in just a little bit. An automobile accelerates from rest at 1 plus 3 root t miles per hour per second. Ooh. Miles per hour per second. Change in velocity over change in time, right? For 9 seconds. What is its velocity after 9 seconds? Okay, that's as easy as plugging in, right? However, letter B, how far does it travel in those 9 seconds? What is it asking for?
The double integral.
I don't know if you want to double integrate. That sounds. It's asking for distance, a change in distance. That's true.
The integral below?
We technically do have acceleration or expression for acceleration. So we do need to integrate. That's true. How did you guys integrate?
Because distance is value, right? Then you go from mile to the feet. You can find velocity.
Why would you go to feet? It doesn't say specifically. I mean, was the answer in feet?
was in feet in the back.
So we can change miles to feet. We can change hours to second. If that would make it a little bit easier. So then we'd have to go ahead and take our 1 plus 3 root t.
I mean, you just have to put it as a row over 3,600 on the outside, right?
Yeah, so you can think about I need to get seconds up, which would be 3,600. That would cancel out with the hours. And then, oh, that's per hours though.
Yes, that's on the bottom.
Yeah. So we would have our 5,280 feet to get rid of our miles, and then we would have our 3,600 seconds to get rid of our hours. So that'd be an expression that would give us what, feet per second squared, technically?
Yeah, but then.
Because then that was also per second. There we go. So that'd be feet per second squared. So now we have an acceleration expression, and so we need to get back to velocity, true?
Yeah.
Which is what you should have been doing for A, ultimately.
Or you can just leave the fraction of the outside.
Yeah, we could. But long story short, we do have to integrate. What did you guys do, with bounds or without bounds?
It was with bounds, so it's not plus. Zero is 9, and 0 is 0.
Now the problem is though, how do you integrate a constant? Because that would just give you a constant, right? But we can't say the velocity is constantly that constant. We can only say that that velocity is the amount at 9. So question, what did you guys get for A? You should still have your homework trials out.
63 miles an hour.
Oh, miles per hour still?
Yeah.
Struggle, so you wouldn't have had this yet. Okay, we'll get back to that in a second. Okay. All this tells me is V of 9.
Yeah.
But I need to get an expression for V of t to be able to integrate that back because the velocity is not constant, it's changing. Why would the velocity, no, the velocity, it accelerates from rest, the velocity can't be constant. Does that make sense? Because the acceleration is varying, the velocity is going to be varying. So we need an expression for velocity, so can't I say V of t is equal to the integral from, well, we are going to do plus c, but we have our condition that we can plug in, or technically we also have our at 0 is 0.
Oh.
Either way we go. So that'd be 3/2, 2/3, just 2?
Yeah, 2.
Whether you plug in 9 and 63 or whether you plug in 0, 0, either way you should be able to get rid of that c. Accelerates from rest, right? V of 0 is 0? So when we get to position, we have to find our, how far, is that going to be total distance traveled, or is that going to be displacement? Total distance, yeah, how far it travels, it could change direction. So we would have from 0 to 9 of the absolute value of our V of t. I'm just saying, just based on the question, I don't want you guys to get in your mind that displacement is how far. How far it travels is always total distance.
Yeah.
It doesn't ask us to.
You don't have these split up.
If you were solving by hand. If you were solving by hand, but the problem is you guys said it was in feet per
It's in feet.
It's in feet, yeah.
per.
No, it's
No, it's just because it's how far,
Oh.
so it's just feet.
Hold on, wait. When you integrate again, though, this isn't going to work so well because you integrated with respect to time. Time is measured in seconds, right? So then when you integrated this one, Katrina, this is going back to your unit question from a while ago. When we have miles per hour per second, when we integrate once, the seconds are gone, so that's okay, we have miles per hour, but when we integrate again, can we integrate with respect to t if t is measured in seconds and this unit is miles per hour?
No.
Not correctly. So we'd have to go ahead and consider that. We don't have to, oh, we do go to feet as well.
I mean,
So I would go ahead and throw in that 5,280 over 3,600. Now, you could go ahead and throw it into this expression, or you could solve, and then you could think about, I'm going to have miles per hour times second, and then try to.
I mean, if you do the integral, it does give you the velocity. And
Right, because it's miles per hour, because you multiply the seconds, and so
it's
then
after
it
9
gets rid of.
seconds. So
Right.
in those 9 seconds, that's like the velocity. At once, then you can just.
But the problem is, when you go to integrate again, this is measuring in miles per hour. To get to how far?
Yeah, you can just you get miles per hour, so you just turn that into feet, because you multiply by
Right, which is why I put the 5,280.
Yeah, and that, if you do that and over 3,600, then your units turns out to feet, and that's the answer.
Right, which is why I had to put this, which wasn't there before, because this is in miles per hour currently, which is what I was explaining to everybody. We needed this conversion, because if we're integrating with respect to seconds, that won't work out if this is measured in hours. So Noah was just re-emphasizing what I was already saying. Okay, so I get that conversion, then we'll be good to go. Alan, does that make sense why we had to convert? We just had to make those units match, and then we were good to go. Now, Lucy's question, I heard someone else, and I'm a little surprised that not more people asked it. Number 22 did get a little bit confusing because this whole homework you guys were working on average value, not the whole homework, but it did show up. Hey guys, it'd be nice if I could have a little bit of focus. On number 22, we were working on average value even in the FRQ that we started with today. So why number 22, when they ask you for the very end, the average daily consumption, why did they not show 1 over 24 minus 0?
Because that would get rid of hours, and then you're just like.
Because you have to look at you could look at two different things. You could look at kilowatt hours, but then you could also say, wait a minute, what is C? C is an average. So they were just asking, hey, find C of T. So since this is the rate, since C of T is the rate of average consumption, if we take the integral of the rate, we will have the average consumption. There is no need for us to do the averaging. It's already considered. Does that make sense? Yeah. And then number 25 was our last one. I think it's right here on the next page of the very great speak up. Guys, go 2 pages. Okay. What's our graph of? How many people or the rate?
Where do people in line?
Not how many people in line. Is it?
People per hour.
It's people per hour. Good. So it's going to be the rate of the people that are joining the line. So if it says there are 500 people waiting in line, so at the initial, there are 500 already in line. If the ride can take. I think we talked through this one, didn't we?
It was a bit different.
It's a little bit different.
How long is it?
But I had something up on the board, and I don't believe it was this exact same problem. It was super stinking close.
Yeah, it was similar.
Okay. So that asks how many people are waiting in line. So we have people joining the line at, this is how fast they're going into the line. If we were to take the area under it between noon and I think 5 p.m. is what we're looking at, couldn't we figure out how many people joined the line that entire time and people walked through the entrance into the line? But what else is also going on? 1,500 people are going off of the ride. So long story short, we would take our area under our curve, which we could find geometrically, true. And then we're going to go ahead and that area represents how many people joined minus, what are we going to do with 1,500? That's the rate. Don't we also need to know how long the ride was taking people?
Then you add 500.
Times 5 hours. And then we're asking how many are currently in the line. We have to also add the initial and say, well, there were 500 to begin with. All of these people joined the line, and all these people were going on the ride. Put it all together, and we'll be good to go. So all you have to do to finish it is find the area under the curve. And Brendan. What? Yeah, that's a huge ride that's taking it on. It must be one of those, like, a whole stadium full of people. Soaring over California, but bigger. Anyway, those are the homework questions that we had. Now that we've gotten thoroughly distracted, 8.2 is definitely not due now. It's going to be due the next day, but don't pack up.
I'm just putting
Here's the homework. Got it. Kiddos, area between. Remind me really quickly with the example that is over here on the board. My two functions are, you guys might not be able to see it super clearly, square root of x and x squared. You have a normal square root and normal parabola. How could you find the 0 and the 1 if it wasn't as nice as these functions that have been given to you? Okay. So it's going to be very common when we have area between that we're going to have to find intersections. If we're doing it with our calculator, super easy, get the function, get the zoom how you need it to be, right? But aren't we going to stow away some stuff? Okay, find intersections, we can stow them away, we can use them as our bounds. We are going to be using top minus bottom and right minus left, but when will this get tricky? Maybe if you don't know which one's on top or bottom, and also what if there are 3 intersections, or 4, or 5? Split it up. Sure, we have to split up our bounds, right? But then if we split up our bounds, don't we, even if we know who's on top or who's on bottom to begin with, couldn't the orientation switch past an intersection? So therefore, how could we generalize this a little bit more so that we, number one, don't have to know who's top, who's bottom, who's right, who's left, and we can account for what if there are multiple intersections. Absolute value. So if we were to change this to instead be A is equal to x1 to x2 of the absolute value of top minus bottom. Wait a minute. How does this not only help us with not being able to visualize some of the graphs, but also help us with the intersections? Because the intersections will be the zeros, right? Split up at the zeros, which are the same thing as the intersection. So the absolute value, by definition, will tell us what to do as long as you're doing it correctly. Does that matter based on the orientation, whether it's dx or whether it's dy? And the answer is no. Not at all. So, quick reminder of the steps of what we're going to be doing. You can write it down or you could not. They might give you bounds, and if they give you bounds, just be careful. You're going to have to think absolute value. Check for intersections in between. Otherwise, if you just throw in a top and throw in a bottom and integrate, you might not be accumulating in the proper positive way. If they're natural, that's when we're finding the intersection. You can determine top, bottom, right, left for the easy ones to visualize, but that absolute value is going to be super important. Good thing we reviewed it this year and did it again with total distance travel last section. Kiddos, you can definitely start your homework. I probably should say go ahead and finish it, but we'll go ahead and go over this a little bit more tomorrow with a few examples from our book. Bye, cool kids. See you later, alligators.